Alright, so in 5.4, so we're going to discuss graph of tangent. So we're going to discuss the characteristic of tangent graph and what should be there and how do you actually sketch the graph. So the thing about tangent graph is that I think it is easier for you to sketch compared to the sine and cosine, because for sine and cosine there are like three characteristics that you have to have a look at: the amplitude, the period, the phase shift. But for the case of tangent, there are only two of them and they are very easy to calculate. Alright, so now this is an example of graph of y equal tangent of x. So the thing is that, so when we have a look at graph of sine and cos before, so let me sketch over here. So this is graph of y equal sine of x, and this is going to be graph of y equal cos of x. So the thing about graph of sine x and cos x is that, so the period is going to be given by 2 pi. So one curve of sine and cosine, so that is going to cover from 0 until 2 pi. But that is not going to be the case of a graph of tangent. So what happened is that for the case of y equal tangent of x, so the period is going to be given by pi over b. So that is going to be the formula. Okay, so the reason, if you know previously for this two, the formula is going to be 2 pi over b to find the period. So period is equal to pi over b, because for the basic graph of sine and cosine, so at the top is given by a value of 2 pi for the formula. But for the case of tangent, and because the period is covered by pi, so it's going to be pi over b. Because if you have a look over here, so this is going to be one period of the tangent graph, so it covers from negative pi over 2 to pi over 2. So that is a distance of pi over, so there is a distance of pi over 2 plus pi over 2, so which is going to equal pi. So the distance between those two asymptotes is pi. And this thing over here, so we have seen this previously when we discussed about graph of function. So this is called as being the asymptote, the dotted line. This blue line right here, so it's called as the asymptote. Asymptote means that your function cannot cross the line, so it's going to go very, very, very close to the line, but there is no way that it can cross the line. So that is called as being the asymptote. And of course, when you sketch the tangent graph, so you need to figure out what is going to be, where are the asymptotes, the location of the asymptotes. Okay, all right, so this is going to be the case of the graphs. Let's have a look at the general form of the graph. It's going to be in the form of a tangent bx minus c. And actually, can you have d for graph tangent? Yes, you can also have d, but it's actually not that much important for the case of d, so therefore we are going to exclude the d. So we're only going to discuss the constant a, b, and c, and how do they actually influence the shape of the tangent graph itself. And the thing is that in for the case of a, so it doesn't really influence. It actually does change when the value of a changes, of course, so the graph is going to change as well. But when we do sketching, so there's not going to be much different in terms of the value of a. So therefore, so when we sketch tangent graph of tangent, you don't need to bother with the value of a. You are only going to concentrate on the value of b and also the value of c. Alright, so what happened is that for the case of sketching tangent graph, there are two characteristics that you need to have. So the first one is going to be the vertical asymptote. So you need to know where is going to be the position of the vertical asymptote and how are they calculated using this formula. Okay, so these are actually the asymptote for original graph. So you remember the graph that we referred to before. So these are actually these two numbers, so which is negative pi over 2 and also pi over 2. So just simply put the negative pi over 2 and pi over 2 on the sides, and whatever your value, your function is for bx minus c. Okay, for example, so let's say if I have a function of y equal to tangent x plus pi, so where is going to be my bx minus c? So this is going to be my value of bx minus c. So whatever that goes in the bracket after the tangent, so that is going to be considered as your bx minus c. Okay, so when you simplify this inequality and you solve for x, you find what it is x is going to equal what value. So this is what you're going to achieve. So these two values right here, these are going to be your asymptotes. So I'm going to show you that in the calculation later. Okay, so that is how you solve the inequality. And that is going to be the first characteristic. So the second characteristic that you need, so this is going to be the second, is going to be the midpoint. So you need to find what is going to be the midpoint, so between the two vertical asymptotes. For example, so let's say if you calculated the asymptotes and you solve and you get that this is going to be 2 points A and B, those are going to be vertical asymptotes. So when you sketch, this is going to be A, and on this side this is going to be B. And you also need another point, so which is going to be the middle point between the two of this. And how do you calculate the midpoint? So that is going to be the value of A plus the value of B divided by 2. So that is going to be the midpoint. So here, A plus B over 2. So those are going to be the two characteristics that you need to know before you start sketching for tangent graph. Okay, so this is the difference. So here what I did is I would like to show you so what happened when you vary the value of the A. So in terms of the shape, it actually doesn't make that much difference. But are they different? Yes, they are different. But when we sketch for graph of tangent, we don't have to be worried about the value of A. We don't have to bother with that. So if you notice, the graph in blue is, for this case, my value of A is equal 1. So that is going to be for the case of the graph in blue, for the line in blue. And for the one in red, the A value is equal 3. And the last one is when the value of A that is going to equal 1/3. Okay, of course, when the value of A is bigger, so the bigger the value of A is, which refers to the red over here, so this is going to be the biggest. If you notice, it increased quickly. So what I mean by increase quickly, so if I were to take the point over here, so this one is going to be the highest, followed by the blue, because it's A equal 1, followed by the green, which is A equal 1/3. Okay, so that is what the difference make when you have different value of A. So it tells you how quicker the value and how much increment the value is compared to the lower value, meaning that the higher, the bigger the value of A, so the what do you call that, the faster the graph is going to increase. So if you notice, so this one is very quick to increase. Okay, the red one increased very rapidly compared to the other two values. Okay, now so I'm going to show you this. I'm going to sketch two periods of the function y equal tangent of x plus 3/4 pi. So actually we don't even need two, like I just need one, but yeah, let's try to do it anyway. Okay, so now first of all, so what we're going to need is I'm going to identify the value of B and C. Actually we don't even need to do that. So first I'm going to find the first characteristic, so which is going to be the vertical asymptotes. So let me put over here. So this is us doing the calculation on how to find the vertical asymptotes. Okay, so according to the formula, so it's going to be negative pi over 2, and then I'm going to have to put bx minus c in between, and also pi over 2. So what is going to be our bx minus c for this case? Is going to be whatever that goes between the in the bracket after the tangent. So that's your bx minus c. So now let me put them together. So I'm going to have negative pi over 2 is less than x plus 3/4 pi, okay, is less than pi over 2. Okay, what you have to do is you have to solve for x. So meaning that you only leave x in the middle. Anything else that is not x, so you have to bring it to the left and to the right. Okay, so that actually, when I said that, so I was actually referring to this function right here. We don't need 3/4 pi, so we are going to bring that to the right and also to the left. And because of the minus, because of the plus right here, so when we bring this to the right and to the left, of course it's going to be a minus operation. So therefore I'm going to end up with something like this. I'm going to have negative pi over 2 minus 3 pi over 4, and then I have x in the middle by itself, so that is what we wanted. And then I'm going to have pi over 2 again minus 3 pi over 4. This is inequality. Okay, so instead of an equal sign, we have less than and greater than. Okay, now the operation is going to be the same as usual, as I mentioned to you. So when you have operation that looks like this, when you press your calculator, so just assume that you don't have to add the pi. Just put negative 1/2 minus 3/4 into your calculator. Later, then only multiply your answer by pi. So I'm going to have negative 1 over 2 minus 3 over 4, and according to my calculator I get a value of negative 5 over 4. So of course multiply this by pi, so it's going to be negative 5 over 4, and x is going to be in the middle, and then I'm going to have 1 over 2, so minus 3/4, 3 over 4, and that is going to give us a value of negative pi over 4, negative 1 over 4 or negative pi over 4 when I multiply that by pi. So meaning that when I sketch the tangent graph, so these are going to be my asymptotes. So let me sketch the graph. So let me prepare the axis first. So both values are negative, so I'm going to make it larger on this side. So where is negative pi over 4? So let's say it's going to be somewhere over here. So this is my negative pi over 4, and somewhere over here, so this is going to be my negative 5 pi over 4. So I'm going to draw dotted lines, dotted vertical line on this. Okay, so those are going to be my vertical asymptotes. And of course the next thing that I'm going to need is going to be the midpoint. So what is going to be the value of the mid between the two of this? So let me add another page for me to do the calculation. Okay, so the midpoint, all I have to do is add these 2 points together and divide that by 2. So I'm going to have negative 5 pi over 4 plus negative, so plus negative of pi over 4, divide that by 2. So let's use our calculator. So I'm going to get negative 5 over 4, so minus 1 over 4. Okay, so divide that by 2, so I'm going to get negative 3 over 4 pi, so which is going to be negative 3 pi over 4. So that is going to be the midpoint. So the midpoint over here is going to be somewhere right here, so it's going to be a value of negative 3 pi over 4. So that's going to be our midpoint. Okay, so the tangent, if you have a look at the graph, so it basically looks like this. Okay, and when you have the what I call this, the turning points, so when you start going down like this, the curve, and this is going to touch 0. So that's the basic shape of the tangent graph. So when I want to sketch this, all I have to do is I'm going to have this function goes from up, and then I'm going to have 0, and then it's going to turn and looks like this. So that is going to be my graph of what is the equation of this? 2 tangent x plus 3 over 4 pi. Okay, so if the question asks you to sketch 1 period, so this is where I should stop. This is going to be 1 period. So that's it, 1 period. Okay, but according to the question over here, so we were asked to sketch 2 period. So therefore you can have 1 more. Okay, but it doesn't really matter though. So what is the distance between this? Yeah, the period is going to be pi. Okay, so if I have a negative 1/4 plus 1 over 4 plus 1, so I'm going to get that here for another period. So we know that 1 period is going to be pi. So therefore when we goes on this side, if I wanted to have another period, so we know that there's going to be another vertical axis. So I'm going to have negative pi over 4 plus pi. So that is going to be at 3 pi over 4. So let's see, 3 pi over 4 is going to be somewhere over here. So this is where I'm going to have the other vertical axis. So that's how it's going to look like, all right? And the midpoint, I know that it's going to be somewhere here. So this is going to be my midpoint. So the midpoint is going to be a value of pi over 2. So that is going to be, no, it's going to be positive. It's actually going to be pi over 4. Okay, so that is going to be my midpoint value. And of course you can calculate that. Negative 1/4 plus 3 over 4. Okay, divide that by 2 and such. Okay, you will get a value of pi over 4. And of course when you sketch the graph, so it's going to look like this. So this is what happens when you need 2 period. But usually the question is not going to ask you to use to sketch 2 period. Usually just going to be one of them. So if you only need one of them, so just sketch this part over here, so this side, and you're done. Okay, but for this one, because of 2, so we have to draw the other side as well. And it doesn't matter, you can actually draw this side or this side, so it's totally up to you, so which side you want to draw. Okay, because it doesn't really mention from where to where here. Okay, so that is going to be how you sketch for tangent function. So I have prepared 3 questions for you to try here, so give them a go. So it's going to be very simple. All you have to do is find the vertical asymptotes and the midpoint. And for this one, so don't bother sketching 2 periods, so just sketch 1 period of them. So sketch 1 period of the following functions, okay, just for you to practice on how to do that. And I have put over here the graph of cotangent, secant, and cosecant as well for you. So this is just for your information, so you're not going to be assess on this. So this is just for your knowledge, okay? So that's it. So this is a